already kind of remember this, but just as a reminder. Okay, velocity, speed, acceleration, position. So position is usually X, Y, or S. They use for position or F. Velocity, okay, so listen up, is the kind of like the speed, but it involves direction. So velocity, like usually when we talk about speed, I'm thinking like miles per hour. It doesn't matter what direction I'm going. It just is like whatever my speedometer says. Whereas velocity involves direction. So that's the difference between the two. That's why speed has the absolute value. Because like when you say you're in your car driving on the freeway, you're not going to say you're going negative 70 miles per hour. People think you're weird. So you always just say the positive. So speed's always positive. Acceleration is the second derivative of your velocity function. Average velocity and displacement. I don't know, I should have boxed this up, but that's okay. Average velocity is like the average rate of change. Maybe write that in there. It's just slope formula. So rate of change to average rate of change. It's basically your change in distance over time. So that's what displacement is. It's just the change in position of an object in motion. Okay. It's not your total distance. That involves absolute value. Displacement is like, say your position, I'll say position 1, I don't know, is at -3 and position 2 is at 5. Your displacement then is, never mind. I'm going to have to show that in a different thing. Never mind. Okay. So I tried to do like ones with how you have to explain it. So if you're given like customers inside a store T hours after opening can be modeled by this differential function. Selected values of P are given in the table. Use the table to approximate P prime. So then just pay attention. You want P prime, but you're given P. Okay, so that means that you're going to be doing some kind of slope. Okay, so P prime of 2, just pick the two values that has 2 in the middle of it. Okay, and you're just going to do slope formula. Please don't be the kid that does the x's over the y's because it's just like, you know what I mean? So P prime of 2 is approximately, so that's where you're just going to do slope. So you're going to be doing like your y2, so you're going to be using these values, 52 minus 40. Actually, maybe I should be more specific. This is what we would want. You would do P of 3 minus P of 1 all over 3 minus 1. So you tell the grader that you're doing slope, and then you take the values from the chart. It's 52 minus 40 all over 2. This is such a nice question. I like this one. It's not so bad. And then you just do some math and you get 6. Okay, so for the unit on this, it's literally whatever the unit was on the numerator divided by the denominator. So the unit on the numerator was customers. Right, so customers. So it's going to be customers per hour. So you can just literally just look at the chart, and that's your unit. Don't have to think about it much. Just read in the chart. Okay. Remember, if you don't have your unit, you don't even get the point for the number. So make sure that you have the right unit for those. All right. We're actually going to be doing logistic growth this year, which is very exciting. So just for fun, this is a logistic graph. This one, we're dealing with the height of a tree measured in meters. Can be modeled by this differential function h of t, where t is measured in years. Determine the units of the function. So again, really, it's about realizing you have H prime here, you have regular H, so that means you're going to be doing some kind of rate. The rate is always like change in Y over change in X, right? So you're doing change in Y over change in X, or Y2 minus Y1, whatever it is. So just get your units in the same spot. So look at your Y, think about what your Y would be, okay? Your Y is your height, aka your H, measured in meters. So you would say your meters is the unit on the numerator. And then now you just look at, okay, what's your x-axis? That's t or time. So t is measured in years. So you're going to go meters per year. I did years. That's all you have to do. So just look at the axes. You'll figure it out. Okay. All right. Now to for explaining it. Okay, so the amount of popcorn inside a large popcorn machine at a movie theater can be modeled by this function. Clearly, they don't have nothing better to do. Where P is measured in ounces and T is measured in minutes, known that P prime of 5 is blah, blah, blah. Interpret the meeting. Okay, so the way you talk about it is you have, because obviously this is going to be a rate, or I guess I shouldn't say obviously, but it's got the prime on it. So you know it's going to be some kind of rate of P. So the way you started off is talking about what P is, okay? So you would say, you start off is you would say the amount of popcorn. So you would say the amount of popcorn. And this works for all of them. Geez, this is like, my handwriting's like so bad on this. Popcorn. Maybe I'll zoom in. There you go. Is now you're talking about what's happening to the function. So we're talking about amount of popcorn. And then when you're talking about a rate, this is where you're going to be looking at whether it's positive or negative. So if it's a negative number, okay, if your rate is negative, then you're going to be saying that it's decreasing. So if it was positive, you'd just say increasing, okay? This especially helps this format when you're dealing with a second derivative and it's like kind of hard to explain, okay? So like P of t, for this one, you're talking about what it is before you took the derivative, okay? So before you took the derivative is regular P, so it's amount of popcorn, and that amount is decreasing because it's negative at a rate of 13.461, okay, thank you. Oh, we didn't do the units. At 461, and then your units, remember, would be ounces of popcorn per, and then what's your T? Minutes. At time equals, and then that's where you're going to put in that 5. Okay. So any questions with that? Okay. So why don't you guys try this next one? Okay. So think about, we're talking about P prime. So that first blank is you have to explain what P is. Like before it was like a prime, if that makes sense. Okay. Oh shoot, I didn't put hold on. This got cut off somehow. Sorry. That's P prime of 2. Okay. I realized that. Sorry. Because then you can't do part of it. Bless you. Bless you. Okay. All right, so this one's a little harder because the function you start with is the rate itself. So that's all you say. So the rate that people enter the amusement park, that's what P is. So just explain what P is. So it's the rate. It's not the amount that people are entering, it's the rate, right? And it's positive, so it's increasing. And it's a rate of, now people per hour squared is just kind of janky. You should be writing per hour, per hour. Okay, so people per hour at T equals 2 hours. Okay, the reason it's people per hour is because that's the Y, right? This is the Y, and then this is like the X. So if you're doing a slope, this would be your numerator unit. This would be your denominator unit. So, yeah, makes sense? Okay. So this one is just kind of, they give you random situations. So I gave you a real life one. So from 0 to 8, I'm walking along a tightrope. You didn't even know. You don't even know. Okay. For velocity, yada yada. After taking a few steps, I drop my balancing pole. Oh my gosh. And stops for a moment. Okay. Find my acceleration at the instant she first stops. So they're going to give you some kind of situation. It's usually like they'll give you like starting points, or like when you're done, or when you stop, that kind of thing. So you just have to know, like, pick the information you need and do the certain derivatives you need to get what it's asking. So we already have velocity. Okay, so this is not a position function. Pay attention to that. Okay, so then I need the acceleration at the instant I first stop. So what does that mean? If I stop, which one am I looking at? So is that position being something, velocity, or acceleration? If I'm talking about stopping. No. Okay, stopping means, yeah, I'm not moving, right? So I could stop, but my distance of when I stop could be changing. You know what I mean? Like I could stop after 3 meters, 10 meters, whatever. But like the key with this is stopping means my velocity is 0. Okay, so that means my first thing here is I'm going to take v of t equals 0. So you're going to set your t squared minus 4t plus 3 equal to 0. Okay, the biggest issue on this one, or I've seen, is people factor wrong and everything's totally off. So make sure you're not factoring goofy. Okay, when you're doing this, I mean, a lot of you are pretty good with that, but okay. So you get your 2t values, and then notice that it says it's when I first stop. Okay, so I first stop at t equals 1. Okay, so because it's the first time, you might freak out with the 2 answers, but you really just want the 1. Okay, so now I figured out when, but then now I need to figure out what's my acceleration at that time. Okay, so what I have to tell the grader, so this is where I'm going to be super psycho on the test, right? Is you need to tell the grader that you're taking a derivative. You can't just go straight to A of t. Oh, geez. There we go. Okay, so you can't just start writing A of t and do a derivative. Make sure you're saying you're taking the derivative of v, which is child's play, right? That's easy, right? And then now you're going to throw in the time at which I first stopped. So that's why I'm putting in that 1. And then you get the answer. So -2. And then when you get -2 for something like this, if you're talking about straight up acceleration, it's not like that last one where you're talking about amusement parks and stuff. If you're doing straight up physics, that's fine to say like, oh, did I even put unit on here? I don't think I did. Oh, shoot. Well, whatever. I'm going to write meters per second squared. Okay, so that's the only time where AP is like fine with the squared thing, like the squared time unit is when you're dealing straight up physics. Is there any questions with that? Okay. This one we're gonna kind of run through a little bit. This is all that Robbie stuff with all the different types of things. So velocity, acceleration. What's the vertical velocity when he hits the platform? What's the speed? Highest in the air, moving higher, speeding up, all those things. Okay, so a lot of you are already kind of getting after it right now. What's really cool is all these projectile functions are quadratic because we know things about life. If you throw something, it comes back down. But the reason, honestly, is because we're going off of gravity and then an initial speed. So going off of gravity and initial speed will get your position function and initial time, I guess, that you're starting. But that's what's cool about calculus, isn't it? So velocity and acceleration, you're just taking derivs. So for this one, just make sure you're telling the grader I'm taking f prime. And then if you want to define it as velocity because you're like a little crazy about it, I don't care. But you just have to make sure you define it. And then acceleration, you're doing the second derivative of t. You could also write it as I'm taking the derivative of v if you want. Like either of those are acceptable. They're going to know what you're talking about. And then grand finale if you want to name it a for acceleration. And -32 feet per second is gravity, which is cool, which is constant, you know. All right, vertical velocity when he hits the platform. So if we're working with velocity, okay, you need to know when he hits the platform. Well, he lands at the platform at this time. So that's just like a straight up plug-in scenario. Okay, so to plug in f prime of 2.05, what I would do on your calculator, I just have the graphing. I would go into your table, like type that into your Y1, go into your table and just ask it 2.0, like, and put in your derivative. Shoot, I don't know. I don't have my graphing calculator because it disappeared. So for your calculator stuff, I know this one's an easy derivative to do, but remember it's to put in your derivative, it would be math and then number 9, is it? Or 8? It's 8. 8. And then make sure that when you type this in, you have like the x equals x of the function and then plug in your y1 to do your derivative. Okay, in your y equals. Okay. Then you plug in your 2.05 and you should get -40.6, and this is feet per second. And then speed of that is the absolute value. So velocity has direction because he's going down, you know? So he's going down, but the speed is positive because you don't talk about speed as being negative because it's weird. Okay? Then for this next one, when is he highest in the air? Okay, that's your absolute maximum. Because we know that this is an upside down parabola. You could explain it just saying that it's going from increasing to decreasing. So the time that Robbie is highest in the air is when the f prime of t equals 0 and changes from and actually I shouldn't say just whatever, f of t changes from increasing to decreasing. Do you guys know how to say it if I said f prime? I said f of t. What if I said f prime? Yeah, exactly. Yeah, so positive to negative. So as long as you're paying attention to f of t, like explaining that, that you'll be fine. So that's when you're setting that negative 32t plus 25 equal to 0 and solving it. So that is 0.7812 seconds. That's when he's highest in the air. Oh. Okay, sorry, keep yawning. Okay, when he's moving higher, okay, if you're looking at that with the graph, okay, that's obviously right here. Okay, so the way you can kind of think about like which one you're going to use is like if you're the higher part is like a position, and the fact that he's moving there means you're going to be looking at a derivative. So the moving part means derivative. High, or being high in the air means a position. So for moving higher, you're going to be looking at when the derivative is positive or when f of t is increasing. Okay, so another way to say that in a different kind of way, instead of saying it's like, you guys are pretty good about when is positions increasing, like seeing increasing, you're going to look at first derivative. But this one, if you had moving higher, that's how I kind of break it up. So that's going to be from 0 to that 0.7812. Okay. When is he speeding up? So this one is why I always think of Robbie for this speeding up business. So speeding up, you want to think about that like gravity and where you're going is like working together. So like here I'm slowing down because I'm going against gravity. Like I'm going up, but I'm slowing down because I'm not just shooting up to the stars, right? So gravity is working against me. The time I'm speeding up is when I'm moving down and gravity is pushing me down. So I've got two things kind of working together when I'm talking about speeding up. I need my velocity and my acceleration working together. That's how I think about that one. So like this one is going to be when f prime of t and f double prime of t have the same sign. So think of them as working together. That's why I always think about Robbie for this one is like when I'm going down and gravity's pushing me down, I'm going faster. Okay, it's not working against it. So that one is going to be from the 0.7812 to when he literally lands, which was 2.05. So this was that time. So it landed here. So speeding up. So just think of it as working together. Okay, changing directions. So changing directions, going from going up to going down. That's going to be at when t equals 0.7812 because he's going up and then going down. So you could say f prime of t changes sign. Or what's the other way to say it? Sorry, I'm going kind of fast. Yep. Changes from increasing to decreasing. Avoid the word it all the time. Never write the word it. If you ever write the word it, you're going to get points off, okay? Because you're not specific about what function. Okay. All right, so there's that one. What's his average velocity? So key for this one, you're doing average velocity, okay? If you want, I haven't gotten my death pen out in a while. Do you know what everyone writes on this? Still do it, even in BC. You know what people do? Because they say velocity. So they do this. Death. They do that for the slope. Because they're at least like, okay, you're doing slope. Okay. And you're like, velocity, derivative. Okay, you got to settle down. Because the numerator unit would be feet per second, right? And then the denominator unit is second. This is average acceleration. Okay, so make sure when you're doing average velocity, it's kind of like average rate of change. You're not using your derivatives. You're using like your normal stuff because you want a feet per second unit. So what you have to do for this one is you need to do regular f of 2 minus regular f of 1.2 because you want your units to match. Why didn't I write 12? That was weird. There you go. There you go. So that is negative 26.2 feet per second. And the reason I know it's legit is because it's literally feet over seconds. This one, I feel like in this scenario, I don't know if I care about this, but the vertical distance. So vertical distance, this is all just normal f of t because you're talking about a position. Okay, we're not talking about a rate. We're not talking about acceleration or gravity. So that one, for distance, what you're going to be using is absolute value. So going up, I mean, that doesn't make much of a difference because that you would just take the change from his position at 0.7812 and then when he started. Okay, so that's no matter what going to be positive anyway. So I'm going to take the absolute value because think about it, he's just going up. So like if I took the difference between this y and this y, I'm going to get the same answer, whether I had the absolute value bar there or not. So that one, if you subtract those values, you get 9.766. But then the reason I need the bars is if I needed to figure out this distance, so like from this y to this y, I need to make sure that I get a positive number, not a negative number. So that's why I'm going to take when he landed minus the, or you could just realize that and need to switch it and not deal with absolute value, whatever you want. But you just have to make sure the part of it when he's going down, you have to like count that as like actual like distance. So that's going to be that 25.756. And then if you add them, the total is 35.522 feet. So the part going up and then the part going down, you have to add up. So I felt like I ran through a ton of stuff in like not a lot of time. So I'll come around if this was like kind of confusing. So